Sure.
Hi, everyone. My name is Damakin Bara, and I'm here to talk to you about my project, Daskhub-Enterprise. So the goal of this project was to create a service and a Helm chart that allow you to deploy Jupyter Hub with Dask, which enables multi-user parallel computation. So the components that we used were Kubernetes and Helm, Jupyter Hub, Jupyter Enterprise Gateway, and Dask Gateway, and Redis. And you all should be familiar with everything except these two, which we'll go over in the next two slides. So first, let's talk about Jupyter Enterprise Gateway. In your typical Jupyter Hub service, you're only going to have this left-hand side of this diagram. And so your computations are limited by whatever is allocated to your Jupyter Lab instance here. Jupyter Enterprise Gateway solves this limitation by allowing your notebook kernels to be hosted elsewhere in the cluster so that you're not limited by whatever pod your Jupyter Lab instance has is. Dask Gateway is a parallel computation framework that consists of a Python library that runs on the client and submits jobs to a scheduler in the cluster. And so this client will be your Jupyter notebooks, and the scheduler will run the jobs and host the data on the workers and submit and return the solutions to the client. And so here's the full architecture diagram that I've of the application I've created. And you can see it's the enterprise gateway in the back. I've had to modify these container specs to make sure that the kernels can connect to Dask Gateway, which then can run jobs on the workers. Finally, all of the notebooks can connect to the Redis database read-write data. Okay, let's now run the demo. So we've connected to the cluster, and we can see the status panes on the right here. Let's run these database things. And now let's load a random data. Let's generate a random 2 million by 100 array into the workers. And then we're going to define a single value decomposition computation, and then we're going to run it. And you can see it working now in the cluster by this task stream and this computation graph that shows the progress of the computation, the parallel computations in the cluster. So let's just wait for this to run. I've tried this computation in NumPy with just vanilla NumPy, and what it does is it crashes my kernel. So we're not going to try that because that's been an issue. So we see we can do this computation fairly fast. Oops, we got to wait for it to get into the database. And I've reused a database key. So let's make a new database key, store it, retrieve it, and we have the same matrix. Okay, let's go back to our PowerPoint. So we've gone over the demo. We've shown how it can do a computation that NumPy can't. And we're going to talk about how I developed this program. So basics of debugging, I read error messages, I visited the hosted Jupyter Hub, logged to launch kernels, tried experiments on Dask. But what was really important was this is my first time using Helm. And so really I dug right into the Helm charts that I used and tried to engineer the solution based on what the configurations for the different Helm charts were and try to get all the services to work together via the configurations. Helm upgrade was really important, and also figuring out that I had a resource limitation on the Dask scheduler, and I had to increase the capacity of the cluster by making the compute nodes have higher CPU and memory capability. And that solved the problem. But I had to start a new cluster. And this can be done more elegantly with auto scaling in the future. And finally, I tested database read writes and made sure that everything was Correct. What did I learn? I learned how to use Helm, how to use Helm charts, and how to develop my own chart and try to get the charts to work together. I also learned how to scale cluster to meet the demands of my service, and some forward directions in how to scale it for real world usage. So the next steps and some limitations of my service is I didn't implement snapshots of the volumes in case of failure. I didn't implement proper authentication, TLS, and other authentication. Auto scaling is a big thing, and there were some quirks with using Helm that I wasn't anticipating. Okay, thank you very much, and